Welcome to episode 35 of Forest Focus. I'm your host, Paul Wade, with the Regional Public Affairs and Communications Office. Have you ever wondered why some trees, in certain locations, a lot of trees, are brown and dying? The connection between bark beetles, drought, and tree mortality is the topic of this episode, and how researchers are looking into making trees less attractive to bark beetles, not tree huggers. Here is Jamie Hendricks to explain more.
There is an ongoing conversation in the forest between insects and trees. Are you up for some eavesdropping? Hearing very little? Then you're listening just right. This conversation has no words and no sound. Instead, it uses the language of subtle, aromatic messengers called pheromones. Bark beetles communicate with pheromones to invite others to join them when they are infesting a tree. In forests throughout the West, mass attacks of bark beetles are part of a tapestry of environmental stressors that are killing millions of trees each year. They can do this because overcrowding, warming, drought, and disease diminish the tree's defenses. Many forests have too many trees on the landscape, which creates competition for limited water and space to grow. Together, these environmental stressors weaken trees, making them more vulnerable to infestation. Enter bark beetles, tiny brown insects that are about the size of a grain of rice. Bark beetles spend most of their lives within a tree, feeding and reproducing beneath the bark. California has approximately 200 native species of these tiny creatures, and most support forest health by helping break down vegetation as part of the natural decomposition process. But around 10 species prey on and kill some of our most desirable trees, which contributes to tree mortality in California. And most use pheromones to communicate with each other when they do it. Chris Fettig, a research entomologist with the U.S. Forest Service's Pacific Southwest Research Station, explains.
For a tree to die as a result of bark beetle attacks, that requires what we call a mass attack, a whole bunch of beetles coming together in a very short period of time to overwhelm the tree's defenses. They facilitate that through the release of aggregation pheromone components that say, come here, and they're drawing other beetles in to mass attack that tree.
Fortunately, Forest Service specialists like Chris are researching how bark beetles and other insects communicate so that we can send them the message, do not infest our trees. They have discovered that some bark beetles use another pheromone to send their companions away from a tree.
Once a tree begins to fill up, they switch to production of an anti-aggregation pheromone, which says, hey, this tree's filling up, please disperse.
Welcome to episode 4 of Echoes from the Understory. This series is all about forest health, what it means, why it matters, and how it is secured. Audio gives us boots on the ground connections with our public lands, where we can immerse ourselves in the soundtrack of forest health. In this episode, we'll have a few guides, a specialist called a silviculturist who grows and protects trees on a ranger district in California. With her are 3 entomologists, specialists who represent the research and management side of entomology, which is the study of insects. Dare we call them bug buffs? I think we dare. They'll tell us about a pheromone called verbenone. Bark beetles produce verbenone as a chemical messenger to tell other beetles that this tree is full. Through careful research, specialists have produced a formulation of verbenone in labs, which is now registered in California for safe use. This formulation of verbenone is also referred to rather memorably as splat. When it is applied to tree trunks in small doses or dollops, it tells bark beetles, this tree is full, which then protects the tree from bark beetle infestations. Let's meet our silviculturist, the resident expert of this particular forest.
My name is Kelly Pavlika. I'm the silviculturist on the American River Ranger District of the Tahoe National Forest. So today we are just northeast of Forest Hill in a mixed conifer forest. It's a little bit dense, which is why we're having some bark beetle issues out here. We're going to treat a rust-resistant sugar pine with verbenone to prevent bark beetle attacks.
Our next expert tells us a bit more about verbenone.
I'm Chris Fettig, a research entomologist with the Pacific Southwest Research Station. I have been with the Forest Service a little over 22 years, and most of my research focuses on bark beetles, climate change, wildfire, and their various interactions. From some very applied work, as we're showing you here today, developing tools to protect trees from bark beetles, all the way to looking at the implications of warming and drying on forests and how that might affect something like carbon sequestration and storage at very large scale. So verbenone is actually a pheromone, meaning it's focusing on communication within an individual species. Essentially, the role of verbenone in the bark beetle world is to say, hey, this tree's full, please disperse and colonize the next available tree. And verbenone is produced naturally by several different pathways. One would be within the hindgut of the beetles themselves, primarily through yeast, we believe. And so years ago, the forest entomology community was able to identify what verbenone was, and we were able to synthesize it.
The first formulation of verbenone was registered with the United States Environmental Protection Agency in 1999 for safe use. But finding out how this pheromone might be used to protect trees from bark beetles involved careful research and study. The entomologists started by blowing the compound across beetle antennae, which are those paired feelers that are attached to an insect's head.
If they tweak the antennae, we know that beetle can detect that compound.
Once the researchers confirmed that beetles were responding to the pheromone by twitching those feelers, they put the pheromone in insect traps to determine if it attracted or repelled the beetles. The traps with the pheromone had fewer insects in them, which meant
we have a repellent.
Additionally, the entomologists have also discovered the pheromone has protective power that reaches beyond the tree that received the direct application.
And so, for example, the first time we did that, we lost 1% of additional trees, where in the other plots, we lost 25% of the trees. So pretty big difference.
With the understanding of how researchers discovered the ability of this pheromone to protect trees from bark beetle infestations, we can now move on to the application.
Very, very low toxicity to this product. But verbenone, even though it's a pheromone, it's being used to repel beetles from a tree, and so it's categorized as a pesticide with the state of California. And we, as the Forest Service, follow all the state laws and regulations for any of our applications. So, putting on all the required personal protective equipment, long sleeves, shoes and socks, gloves, eye protection. So I'm Danny Cluck, and I'm an entomologist with Forest Health Protection, State and Private Forestry for Forest Service Region 5. And I cover northeastern California forests, so Modoc, Lassen, Plumas, Tahoe, and Lake Tahoe Basin. I've done a little bit of everything, wildlife, forestry, range, fire, but it wasn't until this forest health opportunity was presented to me. It kind of opened up a whole new world to me about how forest insects and forest diseases are responsible for a lot of what we see on this landscape, in addition to fire, of course. When we get into forest health conditions like we have now with overdense forests, lots of competition among the trees for limited water and nutrients, and then you add drought, which we've had a lot of in the past 20 years, and the trees become very susceptible to beetle attack. Trees' defense is resin, and when they're stressed, they can't produce enough resin to fend off beetle attack. And so I work with the district folks to help make forests more resilient to these pests with, in this case, a pheromone repellent. The tubes come sealed, but you just take a pocket knife, cut the plastic tip off, and then you put this plastic applicator tip on. Then you clip it. And the caulking gun is almost like a syringe. Every pull of the trigger pushes the plunger into the tube, which forces the material out of the tip. About a 1/4-inch bead of material is what you want when you put it on the tree. We'll put 4 what we call dollops on the trunk of the tree, about 6 feet high.
So it has the kind of the viscosity of toothpaste. The color is kind of gray and kind of a floral type smell.
I don't know if I have any better descriptor on that one. That nice floral associated with a lot of conifers. I'm Jackson Audley. I'm an ORISE postdoc at PSW, so the research and development side of the Forest Service. Did my PhD at UC Davis with a Forest Service entomologist, Steve Seibold, and then transitioned over into Chris Fettig's lab. My focus is mostly on bark beetle chemical ecology to help us protect trees from bark beetle outbreaks. The confluence of the forest insects themselves being really interesting, being out in the woods and studying how to protect trees, I was sold.
We're standing in front of a rust-resistant sugar pine. There's a large metal band wrapped around that tree, and that's to keep squirrels from climbing up and getting into the cones before we can harvest them and collect the seed. There's a disease called white pine blister rust that can attack and kill these trees. There's a group that works out of the nursery in Camino that collects samples of trees that show indications of rust resistance. Once it's identified as resistant, we ban them and we start protecting these trees because of the value of the cones.
With 20 million acres of national forests in California, we cannot apply verbenone to every tree in the forest. Instead, dollops of the human-made formulation are applied to high-value trees, which include
definitely these rust-resistant trees. Time and energy has been put in to identify these and then collect cones off of them to put more sugar pine out on the landscape. These always rank right up there as a high-value tree. The other place very common for us to do an individual tree protection would be within a campground. Expanding beyond that, it could be trees that are very important for wildlife. We've talked about protecting nest stands from beetle activity.
Danny is now ready to apply verbenone to the tree. And the process looks a bit like a doctor about to give a tree a vaccination. But this doctor is wearing a hard hat.
I usually try to find one of the crevices of the bark to kind of find an anchor point and then just kind of make a nice dollop. We don't do this every year. We do this when we have drought conditions or increased beetle activity in the forest. That's when it's our time to come out and put this pheromone on the tree and try to get them through this drought window. So we're coming out of an extreme drought situation, so I felt it'd be good to go one more round this summer, and then we'll kind of reevaluate and decide whether we want to do this next year or not.
Forest health professionals also revisit the trees to evaluate how successful the pheromone is in providing protection.
In the context of a research study, we'll come back typically later in the year to see how attack densities are changing. But we'll give it about a full year to come back and base tree mortality on the presence or absence of crown fade.
To battle outbreaks of bark beetles and to address other aspects of forest health, researchers and forest managers are coming together to find solutions to challenges.
PSW, our laboratory, we work very closely with state and private forestry, forest health protection, which Danny's a part of. We develop these projects, we work on them collaboratively. To me, it's much more about the people than anything else.
We met 20 some odd years ago, and in my experience, there's been a history of forest health protection working with research. It may be a situation where Chris has a project in mind. He's just looking for a location. I may know that offhand, or at least I'll have it on my radar as I'm out doing my job in the forest to be like, oh, that would be the perfect spot. And then other times, it's talking to folks like Kelly on the district. We're out here trying to manage the forest, and we have questions. Then I would be calling Jackson or Chris, passing our idea along and see what they think. And then they would go through the process of trying to secure funding, and we would work on the study location.
As we prepare to leave the forest today, Danny answers a question that lingers within some of our minds. Why do we need to intervene? Why should we go through the effort to learn how bark beetles communicate and then use that knowledge to develop products that protect trees from bark beetles?
Nature did its thing in the past, and it probably did it quite well until we started changing the trajectory of these forests into extremely high density. Everything that we see now, or most everything when it comes to disturbance, whether it be fire or bark beetles, is just absolutely extreme compared to what we believe it was historically, where we would have smaller events spread out across the landscape. And here we just have huge events that swallow up vast acreages of land. I don't want to walk away from these stands because I've seen what will happen if we do nothing. To me, it's not an option.
This episode was produced by me, Jamie Henricks. Theme music is from Pixabay. Keep your eyes and ears out for the next episode of Echoes from the Understory.
I'm not finding splat in my scientific terminology, but it definitely is memorable. If there was a dating app that was used by tree species who used verbenone, then each bark beetle interested in meeting would be a swipe left, just saying. Well, thanks to all of our field researchers and to Jamie for sharing an interesting and largely uncovered topic. Hopefully we will hear more about verbenone and its results. Thanks for listening, and if you're interested in sharing or listening to more episodes, search Forest Focus Podcast or look for us wherever you get your podcasts. And if you have questions or suggestions for a show, email us at sm.fs.r5ffpodcast@usda.gov. Until next time, enjoy your public lands. Please remember to recreate responsibly, know before you go, and learn what you can do to prevent wildfires. Take care. This podcast is sponsored by the U.S. Department of Agriculture, Forest Service, and the USDA is an equal opportunity provider, employer, and lender.